Cancer. It's a word that carries so much weight, one of the most dreaded diseases on the planet. But behind all that fear, there's a biological process. It's really just a set of the body's own rules that have been broken. And the amazing thing is, through science and medicine, we're learning not just to understand it, but to actually fight back. So let's dive in and demystify this formidable disease.
And just to get a sense of how urgent this is, just look at this number. Every single year, more than 1 million people in India alone get a cancer diagnosis, and sadly, many die from it. So this isn't some abstract problem, right? It's a huge global health challenge, which is exactly why it's one of the most intense and important areas of medical research today.
So how are we going to tackle such a complex topic? Well, we've got a roadmap. We're going to break it down into 5 clear parts. We'll start with what's actually going wrong at the cellular level. Then we'll distinguish between the different kinds of tumors, look at the causes, explore how we find it, and finally, we'll cover the incredible arsenal of treatments we have to fight it.
All right, let's get right to the heart of it. What is cancer, really? At its most fundamental level, it all kicks off when the body's own rules for growth just get thrown out the window.
I want you to think of your body as this perfectly organized, bustling city. Every single cell has a specific job to do, and there are super strict rules about when they should grow, when they should divide, and eventually, when they should die. This control system is absolutely critical to keep everything running just right.
Now, at the very heart of this control system is a fascinating property called contact inhibition. Normal, healthy cells are kind of like polite people in a crowded room. When they bump up against their neighbors, they just stop growing in that direction. They respect each other's space. Cancer cells? Well, they've completely lost that etiquette. They just ignore all the signals, rudely pushing and piling on top of each other, growing and growing without any control whatsoever.
So, what happens when you have this relentless, uncontrolled division? Well, these outlaw cells have nowhere to go but up and out. They start to build up, creating a physical mass, a lump that we call a tumor. And that's often the very first tangible sign that the body's fundamental rules have been broken. But here's a really crucial point. Not all tumors are the same. In fact, we have to make a very, very important distinction between the two main types. This is key. So, on one hand, you've got benign tumors. These guys pretty much keep to themselves. They stay put right where they started, and for the most part, they cause very little harm. But on the other hand, you have malignant tumors, and these are the ones we actually call cancerous. They're the aggressors. They invade nearby tissues, and they start competing for vital nutrients, literally starving the healthy cells around them. But what truly makes a malignant tumor so incredibly dangerous is its most feared property, metastasis. Think of it like this. A few cells can actually break off from that main tumor, hop into the bloodstream, and use it like a highway to travel to a totally different part of the body. And when they get there, they can start a whole new tumor. This, right here, is what turns a local problem into a body-wide crisis.
So that begs the question, right? What causes a normal, well-behaved cell to just suddenly go rogue like this? Well, the answer often lies in a set of triggers that we call carcinogens.
And these triggers, they come in a few different flavors. You have physical agents, things like the ionizing radiation from X-rays, or even the non-ionizing UV rays from the sun, both of which can damage our DNA. Then there are chemical agents, like the infamous carcinogens you find in tobacco smoke. And believe it or not, there are even biological agents, certain viruses we call oncogenic viruses that can actually cause cancer. But here's the really wild part. The threat doesn't always come from the outside. Our very own cells carry the potential seeds of their own destruction. See, we all have these genes called proto-oncogenes. Think of them like the gas pedal in a car. They're essential for controlled growth, like when we need to heal a cut. But if a carcinogen comes along and damages that gene, it's like the gas pedal gets slammed to the floor and stuck there, leading to that terrifying, uncontrolled acceleration of cell growth.
Okay, so knowing what can cause cancer is one thing, but how in the world do we actually find it once it's hiding inside the body? This brings us to the absolutely critical science of detection.
And I honestly cannot stress this enough. This might be the single most important message in the entire fight against cancer. Finding it early is everything. It just dramatically, hugely increases the chances that the treatment is going to be successful.
The absolute gold standard for getting a definitive diagnosis is something called a biopsy. It might sound a little intimidating, but it's really just a very careful, methodical process. A tiny piece of tissue is taken on a little journey. It's sliced into sections thinner than a sheet of paper. It's stained with special dyes to make all the cell's inner workings pop with color. And then, finally, a pathologist, A cell detective examines it under a microscope, looking for those telltale signs of chaos.
But what about cancers that are deep inside the body? We need a way to see in there without ever making a cut. And that's where imaging technology is our superstar. Think of a standard X-ray as a flat 2D snapshot. A CT scan takes that to the next level, using X-rays to build a detailed 3D model, which lets doctors see a tumor's exact size and shape. And then an MRI, using powerful magnets, goes even deeper, detecting subtle changes inside the tissue itself, revealing clues that other scans might miss entirely.
And this science of detection is just getting more and more precise. We can now design these smart antibodies that act like tiny, heat-seeking missiles for proteins that are only found on cancer cells. With molecular biology, we can literally peek into our own genetic code to find inherited genes that might increase our cancer risk, which allows people to take preventative action. And for blood cancers like leukemia, often the very first clue is a simple blood test that shows a huge, suspicious spike in white blood cell counts.
So, once cancer is detected, what's next? Well, we fight back. And we fight back with an impressive and constantly growing arsenal of treatments.
The most common approaches really form a powerful toolkit. Surgery is the most direct method, physically going in and removing the tumor. Radiation therapy is more like a sniper's rifle, using focused beams of high-energy rays to destroy cancer cells with incredible precision. Chemotherapy is more like a full-scale ground assault, using powerful drugs that travel through the whole body to hunt down and kill cancer cells wherever they might be hiding. And you know what? Often, the best strategy is to combine these forces for the ultimate 1-2 punch.
Now, of course, the immense power of chemotherapy comes at a cost. Its main strategy is to kill any cell that's dividing rapidly, which is a key feature of cancer. The problem is, cancer cells aren't the only rapid dividers in our body. So are the healthy cells in our hair follicles and our bone marrow. And the chemo, well, it can't tell the difference. This leads to that unfortunate collateral damage we're all familiar with, like hair loss or anemia. But this is where things get really exciting. We are now learning how to turn our own bodies into cancer-fighting machines. See, tumor cells can be really sneaky. They often figure out how to hide from our immune system. So we can give patients these things called biological response modifiers, like alpha interferon, which basically act as a massive wake-up call to the immune system, activating it and helping it finally find and destroy the tumor. So, that journey from a single rogue cell to the cutting edge of medicine leaves us with one final big question. As we keep decoding the body's deepest, most complex secrets, where does the future of this fight really lie? Will it be in creating even more precise targeted drugs that attack a tumor's unique weakness? Or will the ultimate victory come from finally learning how to fully unleash the incredible untapped power of our own immune system? That's the question that drives researchers around the world every single day.